Okay, we're going to go over the review questions that I have posted. So the first one, it's looking at the function f of x, which is graphed here. There's no equation for it, but it's been graphed. And so once it asks me some questions, we're looking at part A. It says as x approaches negative infinity. So as our x values go to the left, we want to know what our y values are approaching. And our y values are approaching that green line, which happens at 3. 1, 2, 3. As our x's go to positive infinity, again, we're saying what's going on with our y values. They're also approaching 3. So then we are now looking at, for part C, as our x's approach negative 2. Now remember that this little minus right here means from the left. So we're looking now at approaching our graph, well, actually, our x value of negative 2, but it's saying from the left side, from the negatives. And so we want to know what's happening to our y values. So our y values are going up, 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 up as you get closer. So to show that, we would say to infinity. Now, as our x's approach negative 2, but this time from the right, from the positive stuff, our y values, well, let's see, as we approach from the right, our y values are shooting downward, so we would say to negative infinity. And so both of these, the reason for these questions, it's just a notation, but it's showing us that we know we have a horizontal asymptote at y equals 3, because we know what's happening as our x's get really small or really big. And then from C and D, we know that we have a vertical asymptote because our y values shoot up and shoot down when we get close to an x value of 2. So the next part, we want to know when our graph is increasing. And so when we're increasing, that means that as our x values get big, what's happening to our y values? They need to be going up as well in order to be increasing. So if we hop on our graph, we're looking at the left side here. If we hop on it, as our x's get bigger, our y values are getting bigger. Now at 2, we have to kind of jump over, but we're back on our graph, and still as our x's get bigger, our y values are getting bigger and bigger and bigger and bigger and bigger. So we're actually increasing during the whole stay on our graph. So from negative infinity all the way to 2, and then I'm jumping over 2 because I can't have any x value at 2, all the way to infinity. And so the graph is never decreasing. Our domain is negative infinity to 2, skipping over the 2 again, because we're not defined there. Our range is negative infinity to 3, union 3 to infinity. Again, we don't pass our horizontal asymptote here. It can, but this graph does not. It has a vertical asymptote, we already said that, when x is equal to negative 2, and a horizontal asymptote when y is equal to 3. All right, we're going to cruise on to question number 2. It wants us to basically graph our rational function. So this is our rational function, and we know that it is because it's 2 polynomials that have been divided. And so when that happens, we know we start having those asymptotes. So the first thing we want to check for is the vertical asymptotes. That's when our denominator equals 0 because we're undefined. So we're trying to see, well, when does x squared plus 1 equal 0? Well, that's never. There's no x value that we could put in there to make that 0, so there are no vertical asymptotes. And the next question is if there is a horizontal or a slant. So the horizontal asymptotes, you want to look at the degrees of our polynomial. So the degree of the numerator polynomial is 2, the bottom one is also 2. So if they match, then you're looking at the leading coefficients. So we're going to have y equals, there's a 2 in the front of that x squared, and there's really 1 even though we don't see it. So we're going to have 2 over 1, or we'll just say 2. So y equals 2 is our horizontal asymptote. The next thing it wants us to look for is if it crosses that horizontal. So really it's saying when does our function, which is 2x squared minus 5x minus 3 over x squared plus 1, when does that equal the 2? So to check that, we want to solve that equation. The easiest way to solve a rational equation is to clear out the denominator. So I'm going to multiply both sides by x squared plus 1. And so that's going to get us, once we get rid of those denominators, we're going to have 2x squared minus 5x minus 3 equals, distributing that to 2x squared plus 2. And since I see x squareds in here, I want to try and put everything onto one side of the equation. It looks like it's a quadratic equation, so I'll move the x squared over, and I'm also going to move the 2 over. So when I do that, oh yay, my x squareds cancel. I'm left with negative 5x minus 5 equals 0. So now that's actually a linear equation. So I'm going to add the 5 over, just trying to get x alone. So that's negative 5x equals 5. Divide by negative 5. We get x is equal to negative 1. So that's what we're going to cross. So I'm looking at this, and it says x equals negative 1. And that was when I had a y value, or you could look at the horizontal, of 2. So it crosses at negative 1, 2. The next couple things at once, let's see, intercepts. So let's look at the x-intercepts. So x-intercepts are where you cross the x-axis, so your y values are 0. So that's looking at when our function equals 0. Well, since it's a rational function and it's a fraction, it's equal to 0 when the numerator is. So we're going to set 2x squared minus 5x minus 3 equal to 0. Now that's a quadratic. You can solve that by using the quadratic formula or by factoring. Some of you guys like to guess and check factor. I'll kind of work it out by doing the grouping because I have this 2 in the front. So some of you guys might not like that. So I'm going to do that AC method. So 2 times negative 3 is negative 6. We have negative 5. That's our B term on the bottom. Numbers that multiply to negative 6 and add to negative 5 would be a negative 6 and a 1. So I'm going to replace just the middle term with negative 6x plus 1x, so we're still equal. And then we're going to group. So these first two terms, they have a 2x in common. I'll be left with x minus 3 there. And the next two terms, they don't have anything in common, so we're just going to say a 1. So plus 1. And we'll be left with x minus 3. We know we're on track because these guys match, so we're going to factor that out. And we'll be left with 2x plus 1 is equal to 0. So with that product equal to 0, we know that x minus 3 is 0, which means x equals 3, or 2x plus 1 equals 0, which is x will be negative 1/2. So those are my x-intercepts. I'm going to write them 3, 0, and negative 1/2, 0. All right, and there's one more piece that it wanted, the y-intercepts. And so my y-intercepts are where we cross the y-axis, so that's when our x is 0. So we're going to actually find f of 0, which will be 0 minus 3 over 0 plus 1. So it looks like it'll be negative 3. So that's going to be the point 0, negative 3. So now with all these details that we found out, we're going to graph. So I'm going to sketch that over to the left here. And the first thing you had was there's no vertical asymptotes. Then it says we're going to have a y value or a y horizontal asymptote of 2. So let me get some more markings on here. And so the horizontal asymptote is at 2, so I'm going to draw that. And we don't cross it, so good to keep in mind. And then we have, we do cross it at x equals negative 1, so I'm going to plot that point on here. So negative 1 up 2, so we know we're going to cross right there. We have our x-intercepts are at 3, 0, and negative 1/2, 0. And then we also have a y-intercept of 0, negative 3. So if I just kind of connect the dots with these guys, looks like these guys are going to touch here. Now the horizontal asymptote is something to get closer and closer to, so this is going to get close, but it's not going to cross because we already have that one point across. And then this, I think, is going to bounce up and just get closer and closer to the x-axis. Or not really bounce, but go through that point, and then it still has to continue the end behavior. So we have that graph. We're going to jump over to, we have 3 other rational functions, and we have to find still all of those details. Now you can double check these on Desmos, but for your exam you're going to have to make sure that you can explain all the different parts and why they are what they are. So we're going to start with looking at part B. We're going to find the vertical asymptotes again. Those happen when we set the denominator equal to 0. So we're looking at x minus 1 equal to 0. So we get x is equal to 1. So we have one vertical asymptote. The horizontal asymptote, or slant, has to do with the degrees. So here we have that our degrees are matching each other. So our leading coefficients are just 1. So we're going to have 1 over 1. So it's just 1. So y equals 1 is our horizontal. And then the question is, well, do we cross it? Well, let's set our function x minus 3 over x minus 1 equal to 1. So we'll multiply both sides by x minus 1. And so then our x minus 1s will cancel. We'll have x minus 3 equals x minus 1. Try and get our x's together, and our x's cancel. We get negative 3 equals negative 1. So that's not true, so then we say no, we don't cross. Then we want to find our X-intercept, and so to find the X-intercepts, that's when we set the numerator equal to 0, because it's when our function equals 0, when y is 0. So that's going to be when x minus 3 is 0, which happens when x is 3. So we have 3, 0 is our X-intercept. And we also need to find our Y-intercept. That's when we let x equal 0. So we're going to have f of 0 is 0 minus 3 over 0 minus 1. So that's going to be a positive 3. So 0, 3 is our Y-intercept. So if we plot those details, let's see if we can find some room on here. If we plot those details, it looks like, we'll do our vertical asymptote. Well, let's put some more points on here first. We have x is equal to 1, so this is our vertical asymptote. We never cross those because our function is undefined for that value. We have y equals 1 is our horizontal asymptote, and we're not crossing that guy. We have an x-intercept at 3, 0, and a y-intercept at 0, 3. So that would be here. Since we don't cross our horizontal, we don't cross our vertical, and following our behavior for our asymptotes, it looks like our graph will have these 2 branches on them. And we've graphed a rational function. All right, let's take a look at part C. So going through the same steps again. So we have vertical asymptote. That's when our function's undefined. So that's when our denominator, x squared plus x minus 2, is equal to 0. So this time we have a quadratic. We'll try and factor that. There's 2 and 1, a plus 2 minus 1. So it happens when x is negative 2 or positive 1. Those are our vertical asymptotes. The next thing that we'll want to find is the horizontal or slant asymptote, and that's looking at the degree. So our degrees match, and the coefficients are 1s, so we're going to have y equals 1 for that guy. So kind of highlighting our details. Next, we want to find the x-intercept. Those happen when y is equal to 0. Well, that's when our numerator is equal to 0. So I'm going to set that equal to 0, and we'll factor x and x. Let's see, we need numbers that multiply to negative 8 and add to 2. That will be a 4 and a 2, with 4 being positive. So that happens when x is negative 4 or positive 2. So we have that our x-intercepts will be negative 4, 0, and 2, 0. All right, one more big detail. Actually, I need to go back 1 second before I find the y-intercept, and I forgot to check and see if we cross. And so if we cross the horizontal, that would mean that our function x squared plus 2x minus 8 over x squared plus x minus 2 is supposed to equal 1. We want to see when that happens. So again, clearing out the fraction, we're going to multiply by x squared plus x minus 2 on both sides, x squared plus x minus 2. Those cancel each other out. We're left with x squared plus 2x minus 8 equals x squared plus x minus 2. We'll move our x squareds over to one side, and that cancels those guys out, so we don't have a quadratic anymore. We can move our x over, so it looks like we have x minus 8 equals negative 2. I'll add the 8 over, and it looks like we have x equals 6. So we're going to cross, we are going to cross, yes, and it's going to be at the point 6, 1, as long as I did all that math right. So then the last thing I have to find is any y-intercepts, and that happens when our x is 0. So f of 0 will be negative 8 over negative 2, which is positive 4. So we have 0, 4 is our y-intercept. So now to sketch all those details, we'll make our graph. Put our important points on there. Make sure I have enough marks. And we need the points, let's see, our vertical asymptotes, we have 2 of them this time, at negative 2 and at positive 1. And negative 2, positive 1, we have a horizontal asymptote at y equals 1. And we also have x-intercepts at negative 4, 0, 1, 2, 3, 4, and at 2, 0. And we have a y-intercept at 0, 4. Okay, and the point where they cross, the horizontal, that's going to be 1, 2, 3, 4, 5, 6, up at 1. So based off of where I cross the x-axis on the left side here, it's going to have to look like that branch. This guy's going to have to go up somehow. He can't cross over the horizontal because the only cross was at 6, 1. And so then we have these guys going on. It's going to cross over, but then it's going to still have to hang out next to that horizontal. So it's kind of a weird, funky graph. All right, we got one more on here to practice. So we're going to still, lots of details here. We're going to look at finding the vertical asymptotes first. So that's when x squared plus 6 will equal 0, which it never happens. So again, we don't have vertical asymptotes, similar to the first one. Horizontal asymptotes or slant, that's if the degrees, looking at the degrees of them. So if you look at the degree of the denominator there, it's growing faster. And so it's going to have a horizontal asymptote at y equals 0. Since the denominator is getting so big, that number is really going to approach 0. And let's see, what else do we have? The x, we need to see if we cross. So let's see if we cross that guy. So we want to know when 12 over x squared plus 6 equals 0. Well, that's never going to happen because this fraction is never 0. You can try and clear out the fraction if you don't see that. So x squared plus 6 times x squared plus 6. So we're going to get 12 equals 0. So we know we don't cross. All right. Then we have our x-intercept. That's when our function is equal to 0. Again, we already know that that's not going to happen. So we already just looked at that actually. So none. And we need to see if we have a y-intercept. So our y-intercept happens when we have our x be 0. So f of 0 here will be 12 over 6. So it's 2. So we have 0, 2. So it doesn't feel like we have that much information. But let's see what kind of graph we can make out of this, out of these details. So I'm going to plot some points on here. Let's see, we have 0, 2. We have a horizontal asymptote at y equals 0. And that's all the details that we have. So I know that if I am going to be not crossing my horizontal, I know I'm going to have to get closer to it as my x's get little. And I'm going to also have to get close to those as they get bigger. So that's pretty much what my graph will have to look like. Not bad. Again, you can double check those on Desmos. All right, we're going to look at this next question. This is a polynomial inequality. So we're going to want to be able to find all the zeros of the x to the fourth plus x to the third minus 8x squared minus 12x for that polynomial. So I see that there's a hint there, but I also notice that they all have an x in common. And so if I factor x out, I'm going to have x to the third plus x squared minus 8x minus 12 equal to 0. And so when I'm trying to find all these zeros, and I have this next inside part, I want to try something. I might try grouping, but grouping's not going to work. So remember we had to try synthetic division, and we would look at all the possible zeros. And the possible zeros here would be the factors of the constant term, which is negative 12, over the factors of our leading coefficient, which is 1. So I'm looking at this being the negative 12, and then there's really a 1 in the front. And so that's giving me a lot of possibilities, and I could still list them. Again, these are just the possible zeros, but it would be like plus and minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, all over plus minus 1. And so I was trying to help you out here by giving you a little hint. So if 3 is a 0, that means that should work when I do the synthetic division. So I'm going to use it to try and break apart this polynomial some more. So I have 1, 1, negative 8, negative 12. I bring down the 1, that's 3. I have a 4. We have 12. That's going to be 4, 12. Yay, it does work. So I was really telling you the truth there with that hint. So then this means right now that if I'm looking at factoring that polynomial, I already have the x. I know that that 3 as a 0 means x minus 3 is a factor. And then I want to rewrite that polynomial. That's x squared plus 4x plus 4. So this is all the review from our very first exam. But now our question is changed just a little bit because we're looking at solving an inequality. We want to compare. So I'm going to have to factor that x squared plus 4x. It'll be x plus 2 times x plus 2. And I have the x minus 3 still and the x. So my zeros are going to be x equals 0, 3, and negative 2. Now negative 2 happens twice, so then that makes me try and think about the multiplicity. And the multiplicity of 0 is 1, 3 is 1, and negative 2 is 2 because you see it happening 2 times here. And the reason why that's helpful is because if I'm trying to graph the inequality, I don't have to graph the full polynomial, but that's graphing part of it will be helpful. So I'm looking back up here. It has a 4th degree, so remember the end behavior is both going to be up because it has a leading coefficient that's positive. And I know I touch the x-axis at negative 2, 0, and 3. I'm going to put my end behavior on there. And so the multiplicity, remember, told me that if it was multiplicity of 1, it goes through at that point, if it was odd. If it was even multiplicity, then it did a little bounce. And so I'm going to finish this graph here at negative 2. I'm bouncing, but at 0 I go through and 3 I go through. And so what that tells me is I'm going to be positive all over here because I'm up above. I'm going to be positive here because I'm up above. And I'm going to be positive over here because I'm up above the x-axis. Those are all positive y values. And then for this little section, I am going to be negative because I'm down here. I'm below the x-axis. So if I look back at the question, it wants to know when I'm greater than or equal to 0. That means when I'm positive or 0. And so you can see that I'm positive here on 3 different intervals. Well, actually, because I can equal 0, that means I can actually touch here at negative 2 because that's a 0. I can touch here because that's a 0. And I could touch here because that's a 0. So it's going to be actually from negative infinity all the way up to 0, including the 0, and then from 3 to infinity. And it might look slightly different if it was strictly greater than, because we couldn't actually include the zeros anymore. So this is my answer to the inequality. Those are the places where I am positive or 0. For number 4, when I have a polynomial inequality, these ones are a little harder to graph, like we just did on our polynomial to find the zeros and things. And so we're actually going to do a number line here. And use test points and test values. But we do still need to find the x-intercepts and we want to find our vertical asymptotes because both of these special features are where our graph will change sign from being positive to negative. Now we're mostly concerned right now because greater than or equal to 0 to where we're positive or 0. And so our x-intercepts are again when our numerator equals 0, because that's when our function will be 0. So we're looking at when p squared minus 2p minus 8 is equal to 0. So that's going to be p, and let's see, p times p is p squared. 4 and 2 make an 8, but we need negative 8, negative 2. Let's see. There we go. So that will multiply to negative 8, and it will add to negative 2. So it looks like our values will be p equals 4 and negative 2. Our vertical asymptotes are when our denominator is 0. So that's going to happen when p minus 1 is 0. So that happens when p equals 1. So these are our like critical points we had said before. I'm going to mark them on my number line. So I have negative 2 is the littlest, and then we have a 1 and a 4. And so what we want to do is just test some values in between these intervals and see if we're positive or negative, which then graphically we would be up above or below the x-axis. So to the left of negative 2, I would try testing like negative 3. So I'm thinking about plugging negative 3 into this function, seeing what happens. It might be nice to look at it factored, and that was like p minus 4, p plus 2 over p minus 1. So when I plug a negative 3 in, it's going to be negative 3 minus 4. Well, that's negative. I'm going to have negative 3 plus 2. That's negative. Divided by negative 3 minus 1, which is also negative. So a negative times a negative is positive. Divided by negative makes me negative. So I know I'm going to have all negative stuff in there. And then we're going to do a value in between negative 2 and 1. So maybe 0 would be good to test. So to test 0, it's like 0 minus 4, 0 plus 2, 0 minus 1. And so 0 minus 4 is going to be a negative number, 0 plus 2 is a positive number, 0 minus 1 is a negative number. So when you multiply, negative times positive is negative, divide by negative, you end up with something positive in there. Then we want to test something between 1 and 4, so maybe test 2. And so if we test the number 2, let's see, testing 2, that's going to be plugging in 2 minus 4, we'll have a 2 plus 2, and we'll have a 2 minus 1. So we're going to get something negative times something positive divided by something positive, which ends up being something negative. All right, the last part we want to check, let's see, let's test something bigger than 4. We're going to test a 5. So when I plug in 5, it's going to be 5 minus 4, 5 plus 2, 5 minus 1. So we're going to get something positive times something positive divided by something positive. That's going to be positive. So when we look at the original question, it wanted us to know we were positive or 0. So we know that we're talking about that in-between section and then that section there. Now we need to be a little careful. Negative 2 was an x-intercept, so this is a 0. And 1 was a vertical asymptote, so we're undefined here. So we want to keep that in mind. We never want to touch that value. And at 4, we were a 0. So we do want to include the zeros because we had the equal to part there. And so the intervals we're talking about are from negative 2 to 1, and then from 4 to infinity. This thing to 0.